Hi everyone, in this video I'll be sharing with you the solutions to paper 1 of HL Mathematics Analysis and Approaches May 2022, Time Zone 2 Section B. A lot of the questions in Section B are quite challenging, so I will like to explain to you guys how to do them. As for Section A, because a lot of the questions are actually SL questions, so I will not be going through them with you. So I'll share with you certain tips and tricks on how to answer the questions, especially those linked questions whereby you need the solutions from the previous part to help you to answer the next part. I hope you'll find the resources useful. The first question in section B is question 10. In this question, you're given a probability distribution table and you're given that the expected value is 2. You're required to find the value of P and Q. So there are two concepts you have to know here. Concept number 1 is that the expected value E of X is actually the weighted average. And the weighted average can be obtained by taking the probabilities, each probability, and multiplying with X. Okay, and then the second concept you have to apply here is that the sum of probabilities is equals to 1. So hence you can form two equations because there are two unknowns P and Q here. So first expected value E of X is actually P times 1 plus 0.3 times 2 plus 3 times Q plus 4 times 0.1. Okay, that gives you P plus 0.6 plus 3Q plus 0.4, which simplifies to P plus 3Q plus 1. Okay, since E of X is equals to 2, so P plus 3Q plus 1 equals to 2. That implies that P plus 3Q equals to 1. Okay, that is my first equation. The second equation, right, I have to add up all the probabilities. So the second equation I'm going to write here, P plus 0.3 plus Q plus 0.1 all adds up to 1. So that means that P plus Q equals to 0. Q plus 0.4 equals to 1. So P plus Q is equals to 0.6. That's my second equation. So now that I have two equations, I'm going to solve simultaneously. P plus Q equals to 0.6. Equation 2, P plus 3Q. I'm going to write this above instead. Equation 1, P plus 3Q equals to 1. So I'm going to use elimination method. 2Q equals to 0.4 and Q equals to 0.2. Okay, and since P plus Q equals to 0.6, therefore P plus 0.2 equals to 0.6 and P equals to 0.4. Since we have found in part A that P equals to 0.4 and Q equals to 0.2, I will use that to help me to find the answer to part B. In part B, you are required to find the probability of X greater than 2. So greater than 2, that includes 3 and 4. So we shall add the probabilities of these two values together. So probability of X greater than 2 would be equal to 0.2 plus 0.1, which is 0.3. Okay, I'm going to look at 10C of the question. In 10C, Nikki plays a game with this 4-sided die. In this game, she's allowed to a maximum of 5 rolls. Her score is calculated by adding the results of each roll, and Nikki wins the game if her score is at least 10. So maximum of 5 rolls and score of at least 10. So she rolled 3 times already and has a score of 4. So this question is actually a conditional probability question, whereby she's actually has to score. I let X be her score. Right, she has to score at least 10, greater than or equals to 10. Right, and it's within 5 rolls.
maximum of 5 rows. Right, but she has already rolled 3 times. Right, scores 4 in 3 times. Right, is it possible for her to score a 10 by rolling the 4th time? It's not possible, because if you look at the maximum score at any point in time is actually 4. So it's not possible for her to roll 1 time and win the game and score 10, because currently she only has a score of 4. So 4 plus 4 is only 8. So she probably needs 2 rolls. Since it's a conditional probability, we can ignore the number of rolls in the first 3 times, because it will cancel off. So I'm going to consider only the rolls on the 4th and the 5th time. Okay, so to score a 10, right, you need a minimum sum of 6. But you could have a sum of 7 as well, or a sum of 8. So these are the possible outcomes. You could have 2 3s, 4 and 2, 2 and 4, that gives you a sum of 6. Or you could have 4 and 3, 3 and 4, that gives you a sum of 7. Or you could have 4 and 4, that gives you a sum of 8. Let me tabulate all the probabilities. So I just have to extract it from the table here, and I get all the probabilities here. And I add them all up. It gives me a total of 0.15. So that's the answer for this part of the question. In this question, you're required to find the value of B. Okay. Basically, David has 2 pairs of unbiased 4-sided dice, a yellow and a red pair. Both yellow dice have faces 1, 2, and 3, and 4. So S is the sum obtained by rolling the 2 yellow dice. So this is the probability distribution for that. So now you have another set of dice, 2 red dice, and the first die has faces 1, 2, 2, and 3, and the second die has faces 1, A, and B. So you're supposed to figure out what A and B represent by looking at the probability distribution of the 2 yellow dice. And basically, the probability distribution of the 2 red dice is the same as the distribution for the sum obtained by rolling the yellow pair. So how do we do this question? It's not that straightforward, especially in the last 2 parts, part D and E, usually is more challenging. So what you may like to do is to first look at the last column here. Last column, the sum of 8 is basically probability 1 over 16. So because as shown in this part of the question, your B is larger than A, right? B is larger than A. Oh dear, I don't want, let me erase this part. It's covering up the answers. Okay. So since B is larger than A, so B must be the largest value among the whole set here. So since we have a 3 obtained from the first red die, then how could you get another and to get 8 in total when B is the largest? So I can guess that B is probably equals to 5, because 5 and 3 gives you 8, but I have to check to make sure. Right, the probability of getting a B is 1 over 4, right? Because there's only one B. And the probability of getting an 8 in the first set, sorry, I should have used the letter S instead. It's 8. So the probability of getting a 3 is actually 1/4 as well, as you can see here, this distribution here. So if you do 1/4 times 1/4, it gives you 1/16. That matches the answer here. So I'm pretty sure B is 5. Part of the question 10D, we found B equals to 5. Now I shall proceed to find the value of A, which is in part E. Okay, so in the first part, we figure out that B equals to 5 from the this column of values. Now I should work backwards and look at the second column here. Okay, what could possibly give you a value of 7? There are a few ways that could happen. And one possible way that, since we found b to be 5, is that you could have a 5 on the second red and a 2 on the first red. So if you multiply that together, right, p, whereby the values, the sum is equals to 7, you could get 2 over 4 times 1 over 4. And that gives you 2 over 16, exactly what you have here. So we deduce that probably how the 7 came about. So now we move on to the next value. Okay, 6. How do you think you can get 6? It's probably 2 trees, right? There's no 4 here. So possibly 2 trees. Let's try out. See if A is a tree. If A is a tree, okay, this is question mark. We're testing out. So if A is a 3, that means it's 2 over 4 times 1/4. That gives you 2 over 16. But you have 3 over 16 here. So it's not possible for it to be 3 then. Okay, so there could be an additional value, right? Because to get a 6, you could also have the first red to be a 1 and the second to be a 5. So that's another possible way. It's also 1/4 times 1/4. Right? If you add them up, 1/16 and 2/16, yes, added together, you do get 3 over 16. So my guess is your A is likely to be equals to 3. I'm required to sketch a graph, and the graph is f of x equals to 1 over x squared minus 2x minus 3. I have to indicate asymptotes, maximum and minimum points, or any points of intersection with the coordinate axis. Right, so first of all, we can see in this question, it's already stated that the x cannot be equals to -1 or 3. That tells you that the asymptotes lie there, the vertical asymptotes are there. Then at the same time, all right, so the horizontal asymptote, because y equals to 1 over x squared minus 2x minus 3, as x tends towards infinity, we will get y equals to 1 over infinity, which is 0, right? So that shows that there is a horizontal asymptote. At y equals to 0. Okay, so now we are supposed to find any local maximum or minimum points. Okay, so how do you find that? We have to differentiate. So f of x, first I change it to this form. And I differentiate. Using chain rule. All right, so I get that. Okay, so to find the turning point, I have to equate f prime x equals to 0. Okay, when I do so, I can quickly tell that x is equals to 1. Okay, once I've done that, I like to figure out whether this is a maximum point or minimum point. I could also do a second derivative test, that is to differentiate a second time, but I decide to use the first derivative test. So I have x here. We have x equals to 1. I'm going to substitute x equals to 0 and x equals to 2, and also then first derivative. When I substitute x equals to 0 into expression, as first derivative expression, I can tell that it is positive. This is obviously 0. When I substitute 2 into the expression, I can tell it's negative. So positive slope, 0 slope, negative slope, I can tell it's a maximum. But we're not done yet. We need to find any points of intersection. So because would there be any points would there be any x-intercepts? It's quite unlikely because if I equate this to 0, right, there's no way you can get any x-intercepts simply when you multiply, you bring this forward over, it's all 0. So there won't be any x-intercepts. Let's try y-intercepts. Let's try f0. So let me substitute f0 in there. Okay, there I go. I get negative 1/3. So 0, negative 1/3. Right, now I can start sketching my graph. Right, I know there are two vertical asymptotes. One is at x equals to negative 1. The other is at x equals to 3. Right, that's a turning point at x equals to 1. And that is actually, we need to find out what's the coordinates as well. So now I substitute 1 into the expression. So that gives you minus 4. So it's a negative 1/4. So at 1, it's negative 1/4. Okay, and then that's at 0 is 1/3. So negative 1/3 is here. So I can pretty much sketch my curve now. I know it looks something like that. Right, it's maximum point. And these two parts, because it's asymptotic, it will tend towards 0. Okay, there I go. That's my graph. I have all the points listed. In this question, I'm required to find the inverse of g. As you know by now, the inverse function only exists if the function is a one-to-one function. So in the previous part of the question, we were asked to sketch the graph of g, and it's shown that it's not a one-one function. So hence, that's why in this part of the question, the domain is actually restricted to x is greater than 3 so that it will become a one-one function. So finding the inverse function is pretty easy. First, let y equals to the function itself. Then swap x and y. And we'll try to make y the subject of the formula. But right now, you can see that the denominator is somewhat a quadratic function, so it may be hard to make it a subject. So you might like to do completing a square before you simplify the expression. Okay, so now I'm going to bring the denominator to the other side. Okay, so because I'm trying to make x the subject, I'm going to divide both sides by x. That's the same effect as bringing the x over to the other side. Now I bring the 4 over. I try to combine into a single fraction. Okay, then I square root it. Okay, so there's plus and minus here. So since you're trying to show that it's 1 plus square root 4x squared plus x over x. So out of this plus and minus, we should select the plus. Okay, but even then, you realize that there's some slight difference between the answer that I've written and the answer given in the question. So what is the difference? Because the difference is such that the the square root actually is applicable for the whole entire term inside. So I have to do something to the denominator to make it the same. Okay, maybe I shall rewrite to make it clearer. So the square root here is actually for the whole expression inside here. So since the x is also square rooted, so we must, and in the answer given the question here, the x is not square rooted. So how do we simplify that? Okay, I'm going to multiply the top and bottom by x. So I get 1 plus I multiply the top by x and the bottom by x, so it becomes x squared. So there you go. I get x squared plus x over x squared, and when you square root x squared, you get, okay. So now I have the same version as the one in the question. So G inverse Okay, and in the second part, you're required to find the domain of G inverse. Okay, in question 11b part 2, you're required to state the domain of G inverse. You may already know by now that the domain of G inverse is actually the range of G of x. I have the graph of G of x below, and you can see that with the original domain whereby x is greater than 3, so the section of the graph we are looking at is this portion. I'm highlighting it right now. So for this portion, the range is y will be greater than 0. So the domain of G inverse would be x will be greater than 0. Okay, in this part of the question, you have to find the value of a given that hga equals to pi over 4. Okay, first we know that g of x is equals to 1 over x squared minus 2x minus 3 from the previous question. So I'll first find g of a first. So I just simply replace the x with a. And this is what I get. So hga, the composite function, I will substitute the x in hx. And hx is actually arctan x over 2. So I will get okay, so this is what I get. So because hga is equal to pi over 4, so 1 over 2 tangent pi over 4. Tangent pi over 4 is actually 1. So 1 over 2 a squared minus 2a minus 3 will be equals to 1. I'm going to cross multiply. Expand. And simplify. Okay, you're supposed to show your final answer is actually like this in a surd form, p plus q over 2 root r. So that probably implies that this this expression cannot be factorized. So I'm going to use the quadratic formula. So you know the quadratic formula minus b plus minus square root b squared minus 4ac over 2a. So a here would be 4 plus minus square root negative 4 squared minus 4 over 2 times 2, which is 4 plus minus square root 72 over 4. Okay, and I try to use the expression like to break 72 up into perfect square. So it's 72 is 36 times 2. Okay, I'm running low out of space. So, okay, I can simplify in the next step to get the final answer. But because in the previous, because it's stated here that they want all positive integers, and this is a plus, so I can pretty much ignore the negative sign here. So I'm running out of space. I'll continue here over this little extra space here. So it gives 4 divided by 4 is 1 plus 3 over 2 root 2. And that's my final answer.
In this complex number question, students are given the 2 points z1 and z2, and they are required to multiply z1 with the conjugate of z2. So what is the conjugate of z2? The conjugate of z2 is just a geometrical transformation, which is a reflection of z2 in the real axis. Let me demonstrate and represent it on the diagram. So you can see right now z2 is being reflected in the real axis, and that gives me z2 conjugate. So the argument now becomes minus theta, but the modulus remains the same. So I can represent z2 conjugate as r2 ei minus theta. So we are required to multiply z1 and z2 conjugate. So that gives me r1 ei alpha multiplied by r2 ei minus theta. Okay, I multiply r1, r2. As for the powers of E, I just treat them like indices, I add them together. And I obtain the answer. R1, R2, EI, alpha minus theta. In this next part of the question, you're supposed to show that the real portion of z1 multiplied by conjugate of z2 is actually equal to 0, and that is a right angle triangle. So a lot of times our IB questions are linked, so we have to use the answer to the previous part to answer this part of the question. So z1 multiplied by z2 conjugate is r1, r2, ei alpha minus delta. So I'm going to write this in modulus argument form. So the real part of this expression is actually just the cosine portion, which is here. So I'm going to extract it out and equate it to 0. So hence, cos alpha minus theta is 0. When is cosine equals to 0? When it's 90, right? It's 90 degrees. So since alpha minus theta is actually equals to 90 degrees, so this part of the triangle is 90 degrees. Hence, we can assume that the triangle Z1 O Z2 is actually a right angle triangle. Z1 O Z2 is a right angle triangle.
In C part 1 of the question, you're supposed to express Z1 in terms of Z2, and you're given some other information. You're told that Z1 or Z2 is an equilateral triangle. So that means that the modulus of Z1 would be equals to the modulus of Z2. Okay, so I'm going to write that down. Modulus Z1 equals to modulus of Z2. Okay, and you're told further that Z1 or Z2 is an equilateral triangle. So that implies that the angle between Z1 and Z2 is actually pi over 3, which is 60 degrees. So that means that the argument of Z1, right, minus the argument of Z2 will give you pi over 3. Okay, and so what I can do is I can see some connection there. I'm going to put Z1 over Z2. Z1 over Z2. So that gives me R1 EI alpha over R2 EI theta. Okay, so since this is an equilateral triangle, so we can assume that R1 equals to R2. So I can cancel that way. So when you divide the argument, right, you can subtract them. So Z1 over Z2 gives you EI alpha minus theta. And alpha minus theta, what would this give you? This would be pi over 3. So Z1 over Z2 is equals to EI pi over 3, 60 degrees. Hence, Z1 is equals to Z2 EI pi over 3. Hence, that's how we express Z1 in terms of Z2. See part 2. Hence, show that Z1 squared plus Z2 squared equals to Z1 times Z2. In IB, whenever you see the word hence, means that you have to use the answer in the previous part to help you obtain the next answer. So you definitely have to use C part 1 to help you to find the answer to C part 2. Okay, so how do we simplify Z1 squared plus Z2 squared? So first, because in the previous part, I found Z1 equals to Z2 EI pi over 3. So I'm going to replace my Z1 with that. So that gives me Z2 EI pi over 3 squared plus Z2 squared. So that gives me Z2 squared EI 2 pi over 3 plus Z2 squared. So since Z2 squared is common, I'm going to take that out. Plus 1. So I'm going to simplify this by expressing it in modulus argument form, the EI 2 pi over 3. So that gives me cosine 2 pi over 3 plus I sine 2 pi over 3 plus 1. Okay, so let me simplify and represent the values in the bracket in Cartesian form. So cosine 2 pi over 3 is minus half. Then sine 2 pi over 3 is root 3 over 2 plus 1. So that gives me Z2 squared. So half plus I root 3 over 2. Okay, so let's try to see what this let's try to represent half plus I root 3 over 2 into modulus argument form again. Right, that will give me cosine pi over 3 plus I sine pi over 3. Okay, so I like to express this back into the Euler form. So it gives me Z2 squared equals to EI pi over 3. Okay, so let me break this Z2 squared down. So it's Z2 times Z2 EI pi over 3. So does this look familiar to you? Z2 EI pi over 3, isn't that your Z1? So let me substitute that back in. So I've just shown Z1 squared plus Z2 squared equals to Z1 times Z2. In this question, you're supposed to use the result from C part 2 to show that a squared minus 3b equals to 0. And you're given that z1 and z2 are distinct roots of the equation. If you recall, under the topic of sum and product of roots, okay, for a quadratic function with roots alpha and beta, right? Okay, so the quadratic expression will be like this: z squared minus alpha plus beta z, then plus alpha beta equals to 0. So this is the sum of roots. This is the product of roots. So I'm going to make use of the concept to help me, because right now your alpha and beta is now represented by z1 and z2 respectively. Sorry. z1 times z2. Okay, so now I'm going to transform this expression accordingly. So z1 plus z2 is equivalent to minus a. That's the first expression. The second expression is, because I'm comparing, why do I say z1 plus z2 equals to minus a? Because I'm comparing the a here with this part of the expression, which is equivalent to z1, z2. Then z1 times z2 is equivalent to your b here. So I'm going to form a separate, another expression based on that. Okay, so I'm going to take equation 1 and I'm going to square both sides. So I get z1 squared plus 2z1 z2 plus z2 squared equals to a squared. Okay, so from equation 2, right, I can replace my z1, z2 with b. So I'm going to do that. Okay, so that's and z1 squared plus z2 squared is now equals to a squared. Okay, so I'm going to separate this from the previous working. A squared minus 2b. Okay, so do you still remember in the earlier part, which is in part C, part 2, we found z1 squared plus z2 squared is equals to z1, z2. Right, that's what we proved. So now I'm going to replace z1 squared here plus z2 squared with z1, z2. Okay, so z1, z2 is b, equals to b. So by rearranging, I move the b over, the b on the left-hand side to right-hand side. So 0 will be equals to a squared minus 3b. So I've proven. Come to the last question in section B. So in this question, we have to consider the equation z squared plus az plus 12 equals to 0. And given that alpha minus theta is between 0 to pi, deduce that there's only one equilateral triangle that can be formed from the point O and the roots of the equation. So in previous part of the question, we were given z squared plus az plus b equals to 0. And we have shown that a squared minus 3b is also equal to 0. So there are some similarities between this part with the previous part. Okay, first of all, now the b has been replaced by 12. Okay, and we can use this second part to help us first to find what a is. So a squared minus 3, I'm going to replace the b with 12, equals to 0. So a squared minus 36 equals to 0. Therefore, a squared equals to positive 36. So a equals to plus minus 6. Okay, so I'm going to consider both values of a equals to 6 first. So I get z squared plus 6z plus 12 equals to 0. And I'm going to use my quadratic formula to solve because this is a complex number, so it's unlikely that it can be factorized. So z equals to minus 6 plus minus square root 6 squared minus 4, 1 times positive 12 over 2. So I'm going to get minus 6 plus minus square root 36 minus 48 over 2. And that's minus 6 plus minus square root minus 12 over 2. And that gives me minus 6 plus minus. I'm going to replace the minus 1 with I squared over 2. I simplify this. Okay, that gives me minus 6 plus minus 2 root 3i over 2. Okay, that gives me minus 3 plus minus root 3i over 2. Okay, and then now I'm going to assume I'm running out of space, so I'm going to block this out. So I'm going to assume a equals to minus 6, so that gives me a squared, z squared minus 6z plus 12 equals to 0. Okay, so z equals to positive 6 plus minus. Okay, so minus 6 squared minus 4, 1 and 12 over 2. So it's 6 plus minus square root 8 over 2. So it's almost the same, right? You can see it's almost the same except that it's going to be this part, earlier part, the 2 disappears because it's divided. So it's almost the same, right? Except that instead of minus 3, it's now plus 3, plus minus square root 3i. So you have 2 roots here. So which ones do you think is most probable? One of these roots would form the equilateral triangle. So which pair? Whether is it the a equals to 6 pair or the a equals to minus 6 pair? So let me first try to sketch the diagram. So for minus 3, right, plus root 3i. The first root is this. Well, arctan of root 3 over 3 actually gives you pi over 6. So the basic angle is pi over 6. So this part here will be 5 pi over 6. Then the other minus 3 minus root 3. So you get this, right? So let me use a different color to represent. So the angle here will be 7 pi over 6. Okay. So 7 pi over 6 minus 5 pi over 6, that gives you 2 pi over 6, which is pi over 3. So this is most likely the pair that gives you the equilateral triangle. But let me check again using minus 6. A equals to minus 6. Okay, so we have 3, right? Then root 3 above and minus root 3 below. So the first one is this. So arctan root 3 over 3 is also pi over 6. So here is pi over 6. The angle here is pi over 6. So let's mark out the other angle. 3 minus root 3i will be here. So the angle is all the way here. So that gives you 11 pi over 6. So let's find the difference. 11 pi over 6 minus pi over 6 that would give you 10 pi over 6. So the difference here is 5 pi over 6. So 10 pi over 6, which is 5 pi over 3. Okay. 5 pi over 3. The difference is 5 pi over 3, so this is definitely not it. So this would be the pair that minus 3 plus minus square root 3i would be the pair that gives you the equilateral triangle. And all that for just 3 marks. That's a lot of work. I hope you enjoyed the video. Thank you for watching. Please do not forget to click on the subscribe button for more IB mathematics resources. See you soon.